Hello again. Today we're talking about sampling techniques. What we mean by sampling techniques is the strategy you use to get observations or empirical data to test your hypotheses. So hopefully by now you're at least thinking about variables that you're interested in, maybe that you want to write about for your papers, but also maybe how you might investigate those variables. So the measures, or what we call the operationalizations of those concepts, right? So if it's, let's say, anxiety, a measure or operationalization might be a scale, a multiple item scale about anxiety. Let's say 10 questions asking people how they feel about stuff. We have to get that data, have people take that scale in some way. So soliciting volunteers, recruiting people to take that survey is kind of the sampling technique you use. In other ways, you may have to ask people one by one, hey, do you know a friend, do you know somebody else who might take my survey? That's what we call sort of non-random. The more random samples are a little bit better for a lot of reasons, getting more random people in our surveys and studies and things like that. And that's the real benefit, right? That's the external validity we'll talk about is mapping our real world population with that sample that we gather. So the match between that sample and the population at large that we hope to generalize our results to. So that's sometimes why external validity is called generalizability, or our ability to generalize or say that these findings mean something to a larger swath of people. If you have a bias sample, we'll talk about, that means you did something in your sampling technique that restricted it in some way that you don't have the most representative sample out there, and that bias limits your external validity or your generalizability. I hope all that makes sense after we go through this a little bit more. Anyway, so we're really talking about generalizability and external validity. And I'll mention again that this is chapter 7, if I didn't already. So this is chapter 7 that really talks about sampling techniques in your modeling text. So anyway, sampling, just to start off, remember, is that subset of the population, right? That group of people, maybe rats, maybe zebra finches, right? Maybe people walking around a store. Whatever that set of observations you use to test your hypotheses, that's your sample. That is taken from and hopefully generalizes to some larger population, right? Humans, mammals, something like that. Anyway, so the generalizability is really dependent on who you generalize that sample to, right? So there's populations and there's samples, right? And the closer they are, the better that matches, the more generalizable your results might be, right? We say a sample is biased when there is some mechanism in that sampling technique that is restricting you from getting certain people. Maybe that's a vaccine trial, for example, and they're not sampling the right proportion of people that are eventually going to use that drug, that vaccine, in their clinical trials maybe. That would be a problem, right? Their sample is biased and not including certain people. Anyways, obtaining a representative sample, of course, is part of why we use probability sampling techniques, right? These ways of randomizing who we get. Based on probability, we say equal probabilities exist between different people that may participate in a study. So let's say, it's college students are being recruited for a study. You should have some probability of being in that study if you're a college student. Otherwise, I don't know why you're listening to this. Anyways, sometimes though, we say we can settle for a less than representative or an unrepresentative sample. So that's when we use sort of the non-random sampling techniques, and we may have a little bit of a biased sample in the end because you're using these sampling techniques like we're talking about snowball and other techniques that aren't as random that might lead to homogeneous samples, let's say all of them being male or Caucasian or something like that, which is not ideal, of course, right? Anyway, so populations and samples, right? So the sample comes from that population. Hopefully it looks like it. In this example here, pictorially, you see that there's some sort of equal representation randomly, hopefully, happening there, right? Things like a census would ideally get all of those people on the left of that image. not just some sample of them, right? So one question you should be asking is, what is your population of interest, right? What is the group of people that you hope your study really relates to when you think about your proposals that you're putting together? Who would you hope to generalize to? That's who you should ideally be sampling or trying to sample, right? Anyways, there's different ways of doing this, right? There's biased and there's more representative samples. If you look at these different techniques here, you can see different ways of introducing bias potentially into the technique, and then that would change who is responding to your survey, thus the responses themselves, and the data you get then that you speak about will not necessarily be representative of everybody's opinion that you could have asked if you did it more randomly or more exhaustively, like with a census. So when is it biased? Well, how do we know when it's biased, right? There's various indicators of bias, but it's basically the technique you use, right? The technique you use will result in something that then won't look like who you want it to look like, right? So that metric of match almost, right? You can look at universities and see the proportion of individuals there. If a survey of university students does not map on or match that proportion, we know it's biased, and then we'd have to look to the method, right? So how we get that bias. Maybe we use some sort of convenience sampling, for example. So maybe it was just people who attended an orientation in person were given a paper and pencil survey, or maybe people that clicked on a certain registration issue were given a survey. So only people that clicked that same registration thing got that survey, right? But that convenience limits who you're actually talking to, right? And then the answers that you get. And you'll see a couple examples in your book of this. Also self-selection, of course. People who are, volunteering for studies sometimes are different than people who do not volunteer for studies. So that agreeableness or volunteerism, if the study has anything to do with that, that would be a huge problem, right? Anyways, there's other problems like where you ask people, right? If you're in sort of a downtown area, one of these studies is about a road rage. Of course, where you ask people, where you find these people, is largely going to matter, right? So if, let's say, a website about getting traffic tickets for running red lights, some of you may have gotten one of those, and then they ask you a survey about road rage or, the legality of traffic lights or something like that. You may choose to answer that based on why you're there, right? So that could be definitely a bias that's introduced there. Probability sampling, on the other hand, is sort of the opposite of this, right? This is sort of using randomization in the process. Simple random sampling is largely never done. It's when you know sort of the population, let's say a group of 20 people, you can enter into a computer program, and it randomly gives you 10 of those in one group, 10 in the other group, which is random assignment, really, or just 10 people in your study, and the other people you let go, right? So then you'd randomly select those 10 people to take your survey or be in your study, right? And we'll get to random assignment versus random sampling, but the sampling is the getting people into the study part, not the giving them the different types of conditions or experiences that we'll talk about later in the semester. So there's different types of this probability sample. Cluster sampling is something that's used a lot. You'll see, groups of students, let's say all in Psych 100 are all surveyed, or let's say 10 high schools out of 100 in the county, they give the example, are surveyed pretty exhaustively. So those clusters are tried to capture or at least advertise to all at once to get a large proportion from select groups or instances, let's say one or two sections of a class, let's say. Multi-stage is combining techniques, like let's say using a convenience sample and then randomly sampling from that, or maybe something like, so it could be random and non-random. We'll talk about that. Snowball sampling, where they're asking friends or relatives to take the survey. You could get everybody into a pool like that and then randomly sample from that to try to get representative people from that group that was non-randomly sought after. Anyway, stratified is when you're getting sort of proportions mapped onto, sort of representing some sort of overall schema. Let's say 60% of the population is women, You want to sort of represent that in some way. Oversampling is getting more than you want for statistical, power and things like that. So let's say you're looking for the opinions of a minority group on campus. You may get more than their technical representation to see if you can actually find differences in their opinions versus others. Anyways, and then systematic samples, just using some system at play when doing random sampling, like every third name in a phone book or something like that. The non-probability sampling techniques are like the convenience, using people that you can find easily. Purposive sampling, which is looking for certain people that do health behaviors that are risky, like smoking or something like that, or people who play certain games, for example, or use certain apps. Not that those are health risks. Some might be. Snowball sampling is, like I said, when you ask people to ask a friend or a family member or something like that. So the group snowballs. As you get more people, they get more people, like a snowball gathering steam. And then quota sampling is filling some sort of quota based on something that's non-random, like snowball or something like that, to get one more, let's say, of a certain gender, race, ethnicity sort of classification, something like that. So there's a host of these different techniques, as you can see, and they all have sort of, rationales for why you would use them, right? If you have some sort of limitation, like let's say you need your participants to have some sort of experience, purposive sampling may need to be done, right? If you want to make sure you have genders represented, you may need to use some sort of stratified sample. Or potentially some sort of quota sampling. If you end up not doing as randomly as possible, and you get people to find one more friend, then you end up, basically in that snowball or quota sort of area. Anyway, so in the one sort of probability sampling, it assumes that you have a shot of getting in that study. The other one, it sort of systematically is eliminating people in some way, right? So less random, less generalizable. If you're non-probability sampling. Anyways, remember again, I want to go back to this, random sampling is not random assignment, right? So random sampling is this idea of representing your population, so it increases external validity. Random assignment is something done mostly with true experiments, sometimes with quasi, but it's within true experiments when you're manipulating a variable. You're assigning participants to groups, right? Like people who watch the angry film or the happy film. And within group studies, to more complicate it, everybody experiences all of those conditions. So you just sample people from a population, and then they get all of the different sorts of films that you're going to show. But in a random assignment, using an experimental design, where you have between groups experiments where people are having independent, unique experiences, you only see the happy film or the sad film, maybe, and then get served a bunch of cookies and see if you eat more cookies if you see the sad film. The type of film you see is between subjects, we call that, and unique experiences. And in that case, you want to sort of wash out or eliminate any other differences between those groups. So we randomly put people that we have randomly selected from the population into those two different groups. So we get hopefully just as many men watching the happy film as we have men watching the sad film. Just as many, let's say, people who have experienced, let's say, mild trauma watching the happy film as those watching the sad film. So those little differences sort of equal out or wash out, we say. Anyways, that's how it controls for these confounds, by eliminating them through that random assignment process. And that's what increases the internal validity of the study. So internal validity is a little bit more about cause and effect. External validity is more about representation. Anyway, so what is this external validity, that I keep referring to? It's the generalizability, right? It's whether these results mean something to other people in different contexts, right? Sometimes contexts don't generalize, sometimes participants don't really generalize. So internal validity, that evidence of cause and effect, and that external validity, or that generalizability, or that representation, are kind of like two sides of a coin, I say. As you increase the internal validity, you may decrease external validity, and vice versa, right? So the higher your external validity, the more your representation is, the more you seek that out, even potentially with non-random sampling techniques, you may lose control over the study. You may have less evidence for cause and effect. Anyways, we can get this evidence in a lot of different ways. One way is through frequency claims, we say, or looking at proportions of people, let's say, subscribing to certain attitudes or doing certain behaviors. In those sorts of situations, external validity representation is important. The examples, let's say, if 4 out of 5 doctors say something, you can't select those doctors in a very select way. Those doctors need to be randomly selected. So that if you say 4 out of 5 doctors, that means something, because it's implying almost a representation when you think about it. And in other cases, external validity is not so important. Like if you think about drivers is a good example, the non-probability of selecting, let's say, drivers who are paid drivers. In that case, they've experienced these phenomenon, but also they're more likely to be able to experience the types of phenomena you're asking about in your study. So it's not so unrealistic to use paid drivers, because they're just experiencing the same phenomenon that other drivers would. They're just not out there experiencing it as often. So you can get more of a base rate or more of an experience through getting people like that. And sometimes non-probability samples and research studies make sense if you need certain types of people to answer studies, or for other sorts of rationale. You can seek out people for purposive reasons, like was mentioned earlier. Observational research is sort of the groundwork for this. So some claims for this are based on observational data. So things like, looking at speech patterns or things like that. One example that they give in the book, for example, is gender-based speech patterns, and sort of looking at the link between observations of that and your concept, right? Because it's not about the speech itself, it's speech correlated with something else, right? Like gender or something else. So you can watch these things and then have these sort of evidence at play that the representation is there or whatever. So two major themes here, right? Large samples are good, and they definitely lower your sort of margin of error, we say, which is a good thing, right? So margin of error is sort of your error related to your significance tests, right? Simply said. So the lower the better, right? If it's plus or minus 10, that would be really big. If it's plus or minus 2, that would be pretty small. So if you look at that random sample size of 2,000, that's great, right? You have a low margin of error there. But, that may or may not be representative, right? So that could be another problem, right? So more people better, but large samples are not necessarily more representative than smaller samples. So there's two things at play there, right? The statistical significance you'll get with a large sample sort of butting up against the representation, that if you use only 50 subjects, but you make sure that all of those people are representative of that population of interest, is that not better, right? So finally, there's sort of samples and there's populations, right? Samples are derived from these populations, and the closer they are to each other, the more external validity you probably have, the more generalizable this study is, right? And this internal and external validity, these concepts are really balanced often against each other. So the internal validity, or the cause and effect, the statistical significance, which is actually just a type of validity, right? That can be played against the representation or the meaningfulness of who you get in this study. So those things can be sort of at odds with each other. So samples should look like populations. That helps you have external validity, right? But that technique is also huge in that. So you want to use those more randomized techniques versus those more non-random techniques. Anyways, I hope this helps. Read your book, and of course email with any questions that you might have.